everyone, this is Upendra Kumar Shukla. I am going to discuss the topic area under the curve using integration for IIT JEE Mathematics, right? So I am going to discuss this topic for Unacademy Star Program 2024. So let's discuss it. So here is the outline of my discussion: introduction and motivation, area under curve, problem of JEE and approach to solve, how to solve the problem, and in the last we will discuss the conclusion. Okay, let's start with the introduction and motivation. So concept of elementary geometry allow us to calculate simple figures area like rectangle, circle, area of circle, area of rectangle, but they are inadequate in calculating areas for the complex curve. Okay, like areas between the curve or areas under the curve x-axis and x is equal to a and x is equal to b. So we need integral calculus to calculate the area under the curve and between the curve. So let's discuss this in detail, right? So let's move further. So area under curve, here is the x-axis and here is the y-axis, and we see this is the curve, y is equal to fx, and this is the x is equal to a line, and this is the x is equal to b line, and this is a strip. We have to calculate the area under this curve and x-axis, and x is equal to a and x is equal to b. So in this process we are taking this small strip, okay, and this area of this small strip, this width is delta xi and this width is delta fxi, right? This is the ith strip. Now we can divide this whole area into several strips, okay, n number of strips, and then sum all those areas to get the area between this curve and x-axis, and x is equal to a, x is equal to v. So what we are going to do, this is the area of a strip delta xi fxi, right? Now if we sum over I is equal to n over all n strips that we are dividing, then we will get the area under the curve, right? And if this n is infinite large, very large, if strip we are taking, there are so many strips, right? So it will give the accurate area under the curve. So limit n tending to infinity, sigma I is equal to 1 to n delta xi fxi, it gives the area. Now this is nothing but the summation. You can change it into integration sign for the limit x is equal to a, x is equal to b, right, and fx dx. So this is the integration. X is equal to a, x is equal to b are the limits, lower limit, upper limit, and fx is the function, and dx, x is the variable of integration. Now next I will be taking, now this is the formula from where we can calculate the area under the curve, integral fx dx, x is equal to a to x is equal to b, these are the limits. Now we are taking the problem of JEE and how to approach for solving this problem. Now the question says the area bounded by the curve 4y square is equal to x square, 4 minus x, x minus 2 is equal to, options are given pi by 8, 3 pi by 8, 3 pi by 2, pi by 16, right? So this is the question from JEE Mains to 2021. So this curve 4y square is equal to x square, 4 minus x, x minus 2, we can rewrite it y is equal to x by 4, this is x square by 4, 4 minus x, x minus 2. So we will take the square root to plus minus x by 2, square root of 4 minus x, x minus 2. Now this is the square root of 4 minus x, x minus 2. So 4 minus x and x minus 2 must be positive. 4 minus x, x minus 2 greater than 0. So x must be between 2 and 4. Now as you can understand, this is, suppose this y is equal to, suppose we are taking, so this is something, y is equal to plus minus x by 2 square root of 4 minus x, x minus 2, that means plus minus. So y is equal to plus x by 2 square root of 4 minus x minus 2 is the above y axis, and minus x by 2 square root of 4 minus x minus 2 is below x axis. So that means if you want to plot, and one more point you should note, that x is equal to 4 and x is equal to 2, value of y is 0. So we can plot this graph. At x is equal to 2 it is 0, and x is equal to 4 it is 0. So we are plotting upper half, and similarly y is equal to minus x by 2, lower half will be very similar to upper half. So we are plotting upper half. So y is equal to x by 2 is square root of 4 minus x minus 2. So at x is equal to 2 it is 0, y is 0, and x is equal to 4 it is 0, and definitely in between it is not 0. So it will go like something this. Okay, so this is the curve. Now area you can find out, the whole area that we want to find out, this whole area. So it will be twice of 224 x by 2 is square root of 4 minus x minus 2 dx. Now 2 will cancel out, so it is integral between 2 to 4 x square root of 4 minus x minus 2 dx. Now you see it is ax px plus q form, this x is, and square root of this is if you multiply 4 minus x minus 2, you will get the quadratic equation. That means this is ax square plus bx plus c form. So you can write it this integral. Now to calculate this integral, you have two approaches. So first approach is very common, integral of px plus q, integral square root of ax square plus bx plus c dx. So you can let px plus q is equal to lambda, and this ax square plus bx plus c, you see the derivative of this will be linear function of x, right? So this is the derivative of this, something it looks like. So lambda times 2ax derivative of this square root, whatever you see within square root. So 2ax plus b plus mu. You can find out the lambda and mu, and then you can integrate. But this would be very lengthy process. So what we will do, this is definite integration. So definite integration, we will use the property of definite integration, and one property of definite integration that is very general is integral a to v fx dx is equal to integral a to v f of a plus b minus x dx. So we will be using this. So a and b here is 2 and 4. So 2 plus 4, 6 minus x. If we put 6 minus x right here, so it 2 to 4, 6x in place of 6, x 6 minus x, 4 minus x, 4 minus 6 minus x. So 4 minus 6 minus 2 and x minus 2, and here x minus 4 dx. So see, these two are same. So we can write this also a, and then we will add. So 2a, it will cancel x and x. So it will remain only 6, and integral between 2 to 4 square root of x minus 2, 4 minus x, that will be equal to 2a, because we are adding a and a. So 2a is equal to 6 integral 2 to 4 square root of x minus 2, 4 minus x dx. So this is something we get, but how to integrate this? This is the problem. Now this is square root of something that is x minus 2 x 4 minus x. If you multiply, you will get the quadratic equation again. Now this quadratic equation you can integrate, because it is known square root of ax square plus bx plus c dx, how to integrate, but it would be again lengthy process. So how to approach it? So let y is equal to square root of, let this function under square root y is equal to square root of x minus 2 4 minus x. Let's open x minus 2 4 minus x. So you will get 4 by x minus x square minus 8 plus 2x. Then you will get minus x square plus 4x minus 8 is within square root, and you can write it this as square root 1 minus x square plus 9 minus 6x. You can write this again, y is equal to square root of 1 minus x minus 3 square. See, if you square this, y square is equal to 1 minus x minus 3 square. Now you are getting equation of circle, and you know the area of the circle. So once you know the radius, you can calculate this integral very easily. So the approach is this. Okay. Now we are transposing this term x minus 3 whole square on the left hand side. Then you will get x minus 3 ka whole square plus y square is equal to 1. That's the circle with the center 3 0 and radius 1, right? So this is the radius 1 and center 3 0. So we can plot this. So this is the circle, this is the half circle, upper half portion we are showing. So 224 square root 1 minus x minus 3 whole square dx we can write. So this you will get pi by 2, because pi r square here is 1 square, so pi, and but it is the whole circle area, but this is half circle, so this will give you pi by 2, right? But we get 2a is equal to 6 and integral 2 to 4, and we have converted the inside integral. If you see this integral we have converted into this 1 minus x minus 3 square, right? So we can see we have converted into 2a is equal to 6, 2 to 4 square root of 1 minus x minus 3 square dx. So this we get pi by 2 into 6. So 2 will cancel 6 by the factor of 3. So this is 3 pi. So a is equal to 3 pi by 2. This is the final answer. So without integration, this approach you are following to get the area between the curve. Okay, thank you so much, and in the next lecture we will discuss more about the area calculation between the curves, different types of the curves. See you again in the next lecture. Thank you so much.